going to walk through two examples where we're going to compute the Laplace transform of a function. To make things easier, I've written down a table of transforms that we can use along with the linearity and the translation properties. In example 1, we are going to find the Laplace transform of 3e to the 2t minus 5 sine of 4t. Let's begin by using the linearity property, and let's split our transform into two transforms. We can write this as 3 times the Laplace transform of e to the 2t. The constant just comes out in front, and then we have minus 5 times the Laplace transform of sine of 4t. We need to find the transform of this exponential function and then the sine function. To do that, let's go ahead and let's write down the general formulas that we're going to need. The Laplace transform of e to the at times f of t is just f of s minus a. So let's make a note here. In our original function, we can think of this as e to the at times 1. So our f of t is going to equal 1. Now let's write down the formula for sine. The Laplace transform of sine kt is equal to k all divided by the quantity s squared plus k squared. Now let's see what this equals. We have a 3, and the Laplace transform of e to the 2t is going to be f of s minus a, where a is equal to 2, and our f of t is equal to 1. So let's write down up here that the Laplace transform of 1 is equal to 1 over s. So our s is going to become s minus 2. This gives us 3 times 1 all over s minus 2. I think that was the hard one. And then we have a minus 5. Now we have k over s squared plus k squared. K is equal to 4. So we have a 4 in the numerator, and then the denominator is s squared plus 4 squared, so that's plus 16. This gives us a final answer of 3, all divided by s minus 2 minus 20, all divided by s squared plus 16. And there's our final answer. I always think the Laplace transforms are going to be easy, but there's so many details that go into finding each transform. Let's look at our second example. We're going to find the Laplace transform of e to the 3t times t squared. We're going to use a formula that we used in our first example, and that formula is the Laplace transform of e to the at times f of t is equal to f of s minus a. Our a is equal to 3, and then our f of t is equal to t squared. So let's write down that f of t is equal to t squared. We need to find the transform of this. So let's use the formula that the Laplace transform of t to the n is equal to n factorial all over s to the n plus 1. Using that formula, we can find that the Laplace transform of t squared is going to be 2 factorial, which is just 2, all divided by s to the 2 plus 1, so that's s cubed. Now we can go ahead and compute the Laplace transform of e to the 3t times t squared. Let's look right up here. This transform is f of s minus a, and remember that a is equal to 3. So let's write this as f of s minus 3. And then this is equal to our f of s. So all we have to do is replace s with s minus 3. And this gives us 2 all divided by s minus 3 quantity cubed. And there's our answer. And that's it. You've now seen how to compute some complicated Laplace transforms, and you should be all set to work through some similar problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.